Hello dear student, welcome to the session on GATE PYQs related to power system subject. So this is our second session. In first session, we discussed one more questions related to basics and line parameter calculation chapter. Now in this session, we will see two more questions on same chapter. Let's move on to the first question. See, in this question it is clearly mentioned, consider an overhead transmission line, three-phase 50Hz balanced system with conductors located at the vertices of an equilateral triangle, DAB, DBC, DCA given, that is 1 meter. The resistance of the conductors are neglected. The geometric mean radius of each conductor is 0.01 meters. Neglecting the effect of ground, the magnitude of positive sequence reactance in ohms per kilometer, round off to 3 decimal places is. Okay, we need to give the answer up to what? 3 decimal places. Okay. Now let's see how to answer this question. See, it is an equilateral spacing. That's what clearly mentioned in the problem. DAB, DBC, DCA same. That itself is saying it is an equilateral spacing or symmetrical spacing. That means the conductors are arranged to form an equilateral triangle, or indirectly the conductors are placed such that the arrangement is forming an equilateral triangle, or the conductors are located at the vertices of what? Equilateral triangle. So whatever the way the question is given, it is nothing but symmetrical spacing or equilateral spacing. Okay. So for an equilateral spacing, what is the inductance per phase of a 3-phase transmission line? And don't confuse here, since he has mentioned positive sequence reactance and original balanced 3-phase system reactance, same. Clear, sir? Positive sequence system and original balanced 3-phase system are what? Same. There is no difference. So that's why don't confuse. Okay, just to create a confuse, he has mentioned positive sequence reactance instead of simply saying a reactance. Okay, positive sequence reactance or simply reactance of the transmission line are what? Same. Okay, now what is the formula for positive sequence reactance or reactance? X equal to 2 pi FL, where L is the inductance per phase. What is the formula for inductance per phase for equilateral spacing? For equilateral spacing, it is what? 2 into 10 power minus 7 ln of d by r dash. Otherwise, 2 into 10 power minus 7 ln of GMD by GMR. Better. Okay. Clear? What is GMD now? GMD is what? Simply D for equilateral spacing. For equilateral spacing, GMD is nothing but what? D only. Okay. That means DAB, DBC, DCA is what? D. That is equal to what? 1 meter. So GMR means what? R dash. Truly speaking, for equilateral spacing, GMR means R dash. Directly GMR is given, correct or not? The geometric mean radius is given. Okay, R dash value itself is given. What is that? 0.01 meters. Okay, now let's substitute, and is asking to calculate ohms per kilometer. Okay, better to calculate the inductance also in Henry per kilometer. Actually, the formula is Henry per meter. But if you want to get Henry per kilometer, better to write here 10 power minus 4. Let's see. 10 power minus 4. I just written here. Because 10 power minus 3 coming to the denominator, that become 10 power 3 meter, that become kilometers. So, directly whatever the answer I get by substituting here, that is Henry per kilometer. Clear? Now, so this is in Henry per kilometer. Now, if I solve this, we get 9.2103 into 10 power minus 4 Henry per kilometer. Now if you multiply this answer with 100 pi, so that is the answer for the question. Okay, let's multiply this with 100 pi because x equal to omega L. Now what is omega L? Omega 100 pi, 2 pi into 50. Okay, let me write that, 2 pi into 50 into 9.2103 into 10 power minus 4, and this is in ohms per kilometer. Henry per kilometer multiplied with omega will give you ohms per kilometer. Now the answer is 0.2893 ohms per kilometer. So what is the answer now? Round off to 3 digits. So that's why 0.289. Okay. So you should enter 0.289. So numerical answer type questions, you should be very, very careful. Okay. Any small mistake you have done, you end up with wrong answer. Okay, clear? So he is asking to calculate in ohms per kilometer. So we calculated in ohms per kilometer, and the final answer is 0.289. Okay. Now we'll move on to the next question. Let's see the second question. A single phase transmission line has two conductors, each of 10 mm radius. These are fixed at center to center distance of 1 meter in a horizontal plane. This is now converted to a three-phase transmission line by introducing a third conductor of same radius. This conductor is fixed at an equal distance d from the two single-phase conductors. The three-phase line is fully transposed. The positive sequence inductance per phase of the three-phase system is 5% more than that of the inductance per conductor of the single-phase system. The distance d in meters is, if you really notice, we have initially a single phase system, right? Single phase system. That means we have two conductors. What is the distance between them? Center to center distance is 1 meter. 1 meter. Now a third conductor is introduced such that it is located at an equal distance from the single phase transmission line two conductors. Let's assume this is A, B, and now what? C. So after introducing a third conductor, we form what? A three-phase system, but this is what? D and D. This D is unknown, that we need to calculate. But what is the condition he has mentioned? The inductance per phase of a three-phase system is what? 5% more. 5% more means 1.05 times what? Inductance of a single-phase transmission line, or inductance per conductor of a single-phase transmission line. Okay? So if this is the case, what is the value of D? Now D is coming into picture here. Clear? But first we can calculate L single phase. What is the formula for L single phase? L single phase is 2 into 10 power minus 7 ln of spacing between the conductors. Initially what? Only these two conductors are there. What is the spacing between them? 1. And R dash. R dash is 0.7788 times what? R. What is R given? 0.01 meters. 10 mm means 0.01. So I will get this in Henry per meter. If I solve this, we get 9.71 into 10 power minus 7 Henry per meter. Clear? Now tell me, what is the inductance of three-phase system per phase? 1.05 times this now. 1.05 times the answer. 9.71 into 10 power minus 7. Let's see what is this value. 10.195 into 10 power minus 7 Henry per meter. Now, what is the formula for inductance per phase of a three-phase system? The formula is 2 into 10 power minus 7 ln of GMD by GMR. Tell me what is the GMD? GMD is cube root of XYZ. What is this X? Distance from A phase to B phase. Y? Distance from B phase to C phase. Z? Distance from C phase to A phase. A to B distance 1 meter. B to C distance D, and C to A also D. So let's see this. 1 into D into D. So 1 into D square, simply D square. D unknown. Now tell me, what is the GMR? Again, GMR is what? R dash only. GMR is R dash. Okay, clear? Now R dash means 0.7788 into R. R is what now? 0.01. So this is in meters. Okay. Now let's substitute and calculate what is D value. Okay. Let's see. So 2 into 10 power minus 7 ln of GMD. GMD is cube root of D square by 0.7788 into 0.01. Now this is equivalent to what? We already did this. 10.195. Yeah, 10.195 into 10 power minus 7. So 10 power minus 7, 10 power minus 7, cancel it. Okay. Now what I get now? Ln of cube root of D square by 0.7788 into 0.01, that is equal to what? 10.195 divided with 2. So that is 5.098 approximately. Okay. Now how to write this? Since it is a ln function, you can do e power on both sides. So directly here e power something and ln get cancelled. Directly I am writing cube root of D square equal to, cube root of D square by 0.7788 into 0.01, right? So that is equal to e power 5.098. Now its value is 163.682. Now what I can write, cube root of d square equal to cube root of d square is equal to what? This term you can multiply here. So what I get? 0.7788 into 0.01 into 163.682. So this value is 1.2747. Now, how to calculate the value of d now finally? Okay. So we can write like this. D equal to, now here what? Cube root of d square, right? If you write whole cube on the both side, okay, and whole power 1 by 2 on the both sides, so that we will get it final answer. Otherwise this is what? D power I can write 2 by 3. D power 2 by 3 is this 1.2747. From this what is D? 1.2747 whole power 3 by 2. Now this value is 1.439 meters. 1.439 meters. So that is the final answer. Okay, clear? So he is asking in meters only now. Yeah, should be very careful with the units. The distance d in meters is. Okay, so what is the answer? 1.439 meters. So that is the final answer. 1.439 meters. Clear? See again, let's see what is given here. Is mentioned there are two conductors forming a single phase system, and what else mentioned is the third conductor is introduced, that is at the same distance from the existing two conductors, so as to form a three phase system. And inductance per phase of a three phase system is 1.05 times the inductance per conductor of a single phase system. So inductance per conductor you can directly calculate from the given data. Now inductance per phase we can calculate 1.05 times that value. Now inductance per phase formula in terms of d is what now? 2 into 10 power minus 7 ln of cube root of d square by r dash. R dash value known, only unknown is what? D. That's we are calculated using another simple steps. Okay, clear? So the question is what? Very simple but bit lengthy. Okay, that is why it is given for what? 2 marks. But if you are very good in practice, no, then you can avoid many steps here. Directly you can do the calculation. Okay, so we'll move on to the next question. Let's see this question. A composite conductor of a three conductor system of radius r each is shown below. The conductors are arranged as shown below. The geometric mean radius GMR in centimeter of the composite conductor is KR. Okay, KR, and the value of K is, that means he is clearly mentioned GMR is what now? K times the R. Now tell me, how many conductors here? 3 conductors. They belongs to what now? Same phase. Okay. Now these 3 conductors, 1, 2, 3, let's say 3 conductors. But if you really notice, all the 3 conductors are having same radius, that is what? Capital R, and the distance from first conductor to second conductor is 3R given. But what is the distance from second conductor to third conductor and first conductor to third conductor? Not given. But he has given another hint here. This angle 60, this angle 60. And it's forming a triangle. In a triangle, the total angle is 180 degrees. Now, so what is this angle? Also 60 degrees. If that is the case, these 3 conductors are forming what now? Equilateral triangle. So this is the first thing you should know. This is from basics. This is from simple maths. Okay. If you have to, you need to identify this first. Means conductor 1 to 2 distance is 3R. But to apply the GMR, I should know what is the distance from 2 to 3, even what 1 to 3 also. But how I know that 1 to 3 distance and 2 to 3 distance? By using this logic. What is the logic here? Here angle 60, here angle 60 given. Now this angle is not given, but in a triangle total angle is 180 degrees. So obviously this angle also 60 degrees, means these 3 conductors are forming an equilateral triangle. If that is the case, what is this distance? 3R. What is this distance? 3R. Okay. Now I am writing simply 3 conductors like this, forming what? Equilateral triangle. What is this distance? 3r. What is this distance? 3r. What is this distance? 3r. And radius of every conductor is what now? Again r. Now tell me, since they are forming a symmetry here, what is the GMR? GMR equal to cube root of D11, D12 and D13. That's enough. Now tell me, cube root of, what is D11? R dash. R dash means 0.7788 into capital R is the radius of the conductor 1. Now D12. D12 is the distance from 1 to 2. That is what? 3 times the R. Now distance from 1 to 3. That is also what? 3 times the R. So what I get now? So R cube and whole power 1 by 3. So we can take it out, that R. So what is left? 0.7788 into 3 whole power 1 by 3 times what? R. Okay. Now this is what the answer, K. Correct or not? This is equal to KR. Now what is the value of K is asking. Now tell me, what is K? 0.7788 into 3 whole power 1 by 3. Now this value is 1.913. Okay. So the answer for this question is 1.913. Now we'll move on to the next question. Let's see, in this question, it's a single phase system clearly mentioned, and the radius of, the diameter of the conductors is given 1.6 centimeters. And the spacing between the centers of the conductors is 6 meters. The permittivity of free space, that is epsilon naught, given. The capacitance to ground per kilometer of each line is, the capacitance to ground means what? Better to say CAN. The formula for CAN or CBN, or capacitance to ground is, or capacitance to neutral is 2 pi epsilon naught ln of d by r, where r is the radius of each conductor. Now this is in farad per meter, but he is asking in farad per kilometer, because the capacitance to ground per kilometer is asking. Per kilometer means we need to get it in per kilometer here. Let's see, 2 pi 8.854 into 10 power minus 12 by ln of d. Spacing between the conductors is 6 meters. And radius of conductor is what? The diameter is given 1.6 centimeters. What is the radius? 0.8 centimeters. 0.8 centimeter by 100 is what? 0.008 meters. 008 meters. Okay. So this is in meters now, and numerator also in meters. So the units are satisfied. But have a look here. This is in farad per meter now, but I want farad per kilometer. Then what do you do? This 10 power minus 12, I will take 10 power minus 9. 10 power minus 3, I bring it to denominator. That become what now? 10 power 3 meters. Nothing wrong to say. Kilometers. Clear? So let's solve this. That is our final answer. The answer is 8.403 into 10 power minus 9 farad per kilometer. Okay, but he is asking per kilometer, that's why 8.403 into 10 power minus 9 farads. The answer is this. Clear? So let's see. The option B is the correct one. Clear? So be careful for a single phase transmission line. There are two types of questions can be asked. Capacitance to neutral means 2 pi epsilon naught ln of d by r. But if the question is given, what is the capacitance of single phase line? That is not CAN, CBN, that is CAB. So in that case we get, instead of 2 pi epsilon naught, we get pi epsilon naught. Capacitance of single phase transmission line means in the numerator pi epsilon naught. Capacitance to neutral of a single phase transmission line means 2 pi epsilon naught we get. Okay, careful about this. Now we'll move on to the next question. Yeah, in this question, a single phase transmission line and a telephone line are both symmetrically struck one below the other in a horizontal configuration on a common tower. The shortest and longest distance between the phase and telephone conductors are 2.5 meters and 3 meters respectively. The voltage induced in volts per kilometer in the telephone circuit due to 50 Hz current of 100 amperes in the power circuit is. See, this is a concept, this concept is, or this question is related to concept called communication line interference. See, what is communication line interference? if a power line, here power line is a single phase line, and a communication line actually having two conductors, let us say conductor 1 and conductor 2. If the power line and communication line, power line means let us say AB, single phase line, now two conductors only, are arranged on the same tower, then since these conductors are carrying alternating current, so an alternating magnetic field is produced. That alternating magnetic field links the what? Communication conductors. So that induces the EMF in the communication line. So to calculate the communication line EMF induced, first we need to calculate the total flux linking the communication line. For that we have a simple formula, lambda equal to lambda 1 minus lambda 2. I am not going into the derivation, directly I am writing the lambda equal to 2 into 10 power minus 7 ln of, IA ln of dA2 by dA1 plus IB ln of dB2 by dB1. Maybe you may get a doubt that if it is a three-phase line, what is the formula? Only one extra term will come, IC ln of DC2 by DC1, where dA2 means what? Distance from our A phase to second conductor of communication line. dA1 means what? A to 1 distance. dB1 means B to 1 distance. dB2 means B to 2 distance. Now if you know these distances, and the calculation become very simple. But this formula by default in Weber turns per meter. Okay, clear? But he has clearly mentioned the shortest and longest distance between the between the phase and telephone conductors are 2.5 meters and 3 meters. Indirectly, this distance, let's see, this distance is shortest distance, this is what? Longest distance. This is 2.5 and this is 3 meters. Now similarly, this is 3 meters, and what about this? 2.5 meters. So indirectly, from this what you can understand? dA1, dB2 2.5 meters, dA2 3 meters, dB2 also, dB1 also 3 meters. Okay. Now if we substitute, we get the lambda. So after getting the lambda, we can calculate the voltage. Voltage equal to omega lambda. But very important is here the units. The units as what? Volts per kilometer is asking. But whatever the value we get here, Weber turns per meter. If we substitute here, we get volts per meter. But you have to convert it to volts per kilometer. So you should play with the units. Units are very, very important, Nana. While solving the questions, units are very, very important. If you are not careful with the units, 100% you end up with wrong answers. Especially numerical answer type questions, there is no feedback. Maybe if you do some mistake with the units, maybe you get up with wrong answers. That option may not be there in the 4 options. Again, you can check where you commit a mistake, because it is a MCQ kind of question. But in case of numerical answer type question, whatever the answer you get, the final answer, there is no feedback for correction. Correct or not? So that's why you should be very careful. Chalo. Now we'll go for the substitution here. So what is the substitution? Let's say IA. IA is what now? 100 ampere. What is IB? Since it is a single phase line, IB is minus 100 ampere. Correct or not? For a single phase line, IA equal to minus IB. If IA is 100 ampere, IB equal to minus 100. So let's substitute that. Okay. So 2 into 10 power minus 7 lambda I am calculating. 100 amperes into ln of dA2 means 3 meters by 2.5 minus 100 ln of 2.5 by 3 Weber turns per meter. Now let's see. Here minus ln of 2.5 by 3, I can reverse it and I can make it plus here. Then these two terms are same. So that's why 2 into 10 power minus 7 into 200 ln of 3 by 2.5. If I solve this, we get 72.928 into 10 power minus 7 Weber turns per meter. Okay. But we want omega. Omega equal to, we want voltage, that is omega lambda. Let's substitute here. Omega means 100 pi times what? 72.928 into 10 power minus 7 volts per meter, because it is in Weber turns per meter. So we get volts per meter. But the answer is expecting in volts per kilometer. So the answer for this is 2.291 volts per kilometer. Okay, clear? So I'm sorry, actually this is volts per kilometer only, because instead of 10 power minus 7, I took 10 power minus 4. 10 power minus 7 joules per meter. If I want to convert joules per kilometer directly, so take out 10 power minus 3 and write what in the denominator? Kilometer. So if I solve this, I will get 2.291 joules per kilometer. Now just go back. What is the answer? 2.291. So answer is C, 2.29 joules per kilometer. So this is how we need to solve. Again, so another question can be asked from this topic, like by giving what? Three-phase transmission line. Three-phase transmission line means what? One extra conductor, third conductor. See, now IA ln dA2 by dA1 plus IB ln dB2 by dB1 plus IC ln DC2 by DC1. That is the extra term. So if you know the distance from every conductor to what? Every conductor of three-phase line to the communication line conductor 1 and conductor 2. If you find out these distances, then the answering of this question is very simple. But after one thing you should be careful while answering the three-phase system question. What is, suppose if the current IA is 100 ampere, what is IB? 100 at an angle minus 120. Careful with the substitution. You will get the complex number here. IA 100 angle 0, IB 100 angle minus 120, IC 100 angle what? Plus 120. If it is a three-phase line and is asking for what is the EMF induced in communication line, that is in volts per kilometer. You have to solve like this. Okay, so IA is 100 at an angle 0, IB 100 at an angle minus 120, IC 100 at an angle plus 120. You will get lambda. Let's take the magnitude of that only, because we have to give the answer only magnitude. So if you take the magnitude of lambda, you will get what? One real number only. Magnitude of the complex number is real part only, real number only. I'm sorry, not real part, real number. So that multiplied with what? Omega, you will get the final answer. Clear? So we'll move on to the next question. See, in this question, a lightning stroke discharge impulse current of 10 kiloampere, that is what? Peak value, okay, on a 400 kV transmission line having a surge impedance of 250 ohms. The magnitude of transient over voltage traveling wave either direction, assuming equal distribution from the point of lightning stroke, will be. Indirectly, in this question, it's clearly mentioned that the lightning stroke strikes here exactly at the middle of the line. What is the peak value of lightning discharge current? I. Then how much will be the current divided in both sides? I by 2 and I by 2. The voltage on this side is V, voltage on this side is what? V. Now tell me, what is the formula for V? The current I by 2 into what? Surge impedance Zs. What is the value of I? The peak value of lightning discharge current only. It's not RMS value. So what is the peak value? 10 kiloampere by 2 into surge impedance is what? 250 ohms. If I solve this, we get 1250 kV. So very simple question. The answer is A, 1250 kV. Clear? Now we'll move on to the next question. See, in this question, the conductors of a 10 kilometer long single phase 2-wire line are separated by a distance of 1.5 meters. The diameter of each conductor is 1 centimeter. If the conductors are copper, the inductance of the circuit is, see, inductance of a single phase circuit, not single phase line. That's why what is the formula? For circuit inductance, L circuit. Sometimes he may ask you what is the total inductance of a single phase transmission line. Circuit inductance, total inductance, loop inductance, always same. That is 4 into 10 power minus 7 ln of d by r dash Henry per meter. Now let's see. But he is asking in what? Millihenry. So we can calculate in millihenry per kilometer also. But for that what? 10 power minus 6 I have to take it out. That means we get 0.4. 10 power minus 6 I am taking out. Ln d by r dash. Let's see what I am doing. In the 10 power minus 6, na, 10 power minus 3 henries I can write. That is millihenry. One more 10 power minus 3. I can bring it to denominator. I can write 10 power 3 meters. That is what? Kilometers. So now tell me what is this? 0.4 into ln of. The spacing between the conductors is 1.5 meters. And diameter is given. Careful, not radius. Diameter is 1 centimeter means radius is 0.5 centimeter and divide with 100, 0.005 meters. So numerator is in meter, denominator also in meters. But you should multiply with 0.7788. Here also many people will commit a mistake. Why? Because it's not R, it's R dash, 0.7788 times R. Okay. So if I solve this, we get 2.381 millihenry per kilometer. But is asking for what? 10 kilometer long line. So this should be multiplied with 10 kilometers. So L circuit equal to 10 times 2.381 millihenries. So we get 23.81 millihenries. Now this is the final answer. Okay, so the option is C. Clear? Again, it is also a simple question, but careful, sir. If the same question, when same data is given, if the question is asked like this, what? Instead of asking circuit inductance, is asking what is the inductance per conductor of a single phase transmission line. In that case, instead of 4, you have to take 2. You should be very careful with single phase line. Circuit inductance is always 2 times the inductance of single phase line. Okay, so we'll move on to the next question. Let's see in this question, a single phase overhead line having solid conductors of diameter 1 centimeter. Solid conductors of diameter what? 1 centimeter. Spacing between them is 60 centimeter. The inductance in millihenry per kilometer is. Does he mention inductance of single phase circuit here? Like previous question? No. He is asking the inductance of single phase line only. Inductance of single phase line means what is the formula? L single phase 2 into 10 power minus 7 ln of d by r dash. Okay, clear? Otherwise, this is in what? Henry per kilometer. Sorry, Henry per meter. In millihenry per kilometer, how to write? 0.2 ln of what? D by r dash. Millihenry per kilometer. Let's substitute what I get? 0.2 ln of D is what? 60 by R. R is what? 1 centimeter. Okay. So, sorry, diameter is 1 centimeter. So that R is what now? 0.5 centimeter. But we get 0.7788 into 0.5. Correct or not? R dash now. But tell me, any answer is saying that? No. Because the answer is not given based on this formula. So that means you should modify the formula. How to modify? Remember, sir, ln d by r dash can be replaced with 1 by 4 plus ln d by r. I am not going in detail, remember this. Now if I substitute this here, then what I get? 0.2 into 1 by 4 plus what? Ln d by r. Now you substitute, you will get the answer. 0.2 into 1 by 4 is what? 0.05 plus 0.2 ln d. D is what? 60 centimeter. R is what? 0.5 centimeter. So 60 by 0.5. Now see, this is also correct answer. I am not saying that this is wrong. This is correct. But that option is not there, no? Correct? That option is not there. Check anywhere. 0.2 ln 60 by 0.5 is there. But is this correct? No. 0.2 ln 60 by 0.7788 into 0.5. But that is not there. And this is also not correct. So that's why, what is the best answer? 0.05 plus 0.2 ln 60 by 0.5. So this is the correct answer. Clear? So option C. So remember this. It's very, very important. Ln d by r dash I can replace with 1 by 4 plus ln d by r. This is just for simplification. We can do that. Okay? Clear? And this is very important when you are solving a question without a calculator. Okay? Clear? So we'll move on to the next question now. Yeah, this is the last question from our first chapter. Okay, for equilateral spacing of conductors of an untransposed three-phase line we have. Now tell me, transmission line is what? Equilateral spacing. Equilateral spacing means the conductors are arranged like this. If the conductors are arranged and transposition is not done, conductors are forming equilateral triangle, but the transposition is not done, but still we get LA equal to LB equal to LC. We get balanced network, balanced inductances, balanced impedances, balanced sending end voltage and receiving end voltages. But since the transposition is not done, definitely there exists a communication line interference. Careful about this. Even it is a symmetrical configuration or unsymmetrical configuration. If you have not done the transposition, there exists a communication line interference, 100%. Okay, but what is the difference between symmetrical and unsymmetrical? Symmetrical configuration produce balanced inductances, unsymmetrical configuration produce unbalanced inductances. For unsymmetrical configuration, we get LA not equal to LB not equal to LC. But symmetrical configuration, we get LA, LB, LC are what? Same. Since you have not done the transposition, It might be symmetrical or unsymmetrical configuration. 100% there exists a communication line interference. Okay, now let's see what is the answer. Balanced receiving end voltage and no communication interference. No, it's not correct. Balanced receiving end voltage correct, but there exists a communication line interference. So that's why the answer is what? Balanced receiving end voltage and communication interference. So the best option is C for this question. Okay, so with this we finished the first chapter, gate PYQs. Okay, so we'll meet in the next session. So we will start with performance of transmission lines PYQ questions. Thank you, all the best.